We all know artificial intelligence is incredible, but it has this one giant secret flaw. It just makes stuff up. Today, we're going to dive into how a really powerful idea called a knowledge graph can give AI a memory and a source of truth to stop those hallucinations right in their tracks.
So first, let's get right to the heart of the problem. For all their amazing power, large language models, the brains behind tools like ChatGPT, have a really serious and sometimes kind of funny issue with reality.
It's a wild question, isn't it? I mean, we get these incredibly smart-sounding answers, but every now and then they're just confidently wrong. So why on earth does that happen?
This quote from the source material absolutely nails it. LLMs need to be grounded. Without that anchor in real, connected facts, they just drift. And that's what we call hallucination, when the AI invents something because it sounds statistically right, not because it's actually true.
A great way to think about an LLM is like a genius improv actor. It's been trained on a massive script of all human language, so it knows what words should come next. But here's the thing, there's no fact checker backstage. It's just predicting the next most likely word, not recalling a verified fact, and that is a huge difference.
So how do we fix this? Well, the solution is pretty radical. It involves changing the way we think about data itself. We need to move from just lists of information to a web of interconnected knowledge.
Okay, so look at the old way versus the new way. For decades, we've stuffed our data into these rigid tables and rows. If you want to find a deep connection between things, you have to do these really slow, clunky operations called joins. It's painful. But graph databases, they are built from the ground up just for connections. It's what they do.
Let's quickly break down how a graph works. It's basically made of two things. First, you've got nodes. A node is just a thing, an entity. It could be a person, a product, a company, whatever. It's one of the dots in the network. And this is where the magic happens. The relationships. These aren't just lines connecting the dots. They have meaning. They have a direction and a name. So it's not just Alice is connected to a company, it's Alice works at a company. The relationship itself is what holds all the rich context. Now this is the secret sauce. In a graph, those relationships are treated like real data. They're stored, not calculated every single time you ask a question. And what that means is that jumping from one fact to another and another is, well, it's instantaneous. This is the superpower that lets an AI reason through complex problems in a flash. Okay, so we've got this incredibly powerful way to store connected data. Now let's connect it all back and see how we can use this to literally build a brain for our AI and solve that hallucination problem we started with. What we do is we use that graph database to build something called a knowledge graph, and it's exactly what it sounds like, a structured, queryable map of your organization's reality. It's a source of truth the AI can actually read and understand. So this knowledge graph, it basically becomes the AI's external brain. It's the factual backbone that the LLM was missing all along. Now, before the AI even tries to answer your question, it can go and consult this graph to get the real facts and all the rich context around them. This whole process has a really cool name, Retrieval-Augmented Generation, or just RAG for short. It's the go-to technique for grounding AI right now. The idea is super simple. First, you retrieve the right information from your external source, and believe me, a knowledge graph is the best source, and then you augment the AI's prompt with those facts. Suddenly, the AI has everything it needs to give a truthful answer. But we can take this one giant leap further. We can combine the perfect structured world of the graph with another amazing AI tool, vector search. This is where things get really interesting.
When you put these two together, you get what the source material calls hybrid retrieval. It's like giving the AI two different kinds of intelligence. From the graph, it gets structural intelligence, the hard facts, the how. And from vector search, it gets semantic intelligence, the fuzzy meaning, the what. It's truly the best of both worlds.
Okay, check this out. Let's walk through it, because it's so powerful. Your question comes in. First, vector search goes hunting for ideas that are conceptually similar. That's the what. Then, the graph search takes those results and starts exploring all the ways they are factually, structurally connected to everything else. That's the how. In the end, the AI gets this incredibly rich, contextual, factual package to work with. So you see, this is a huge step up. We've moved way beyond just grabbing a few related sentences from a document. The AI isn't just checking facts anymore. It's retrieving entire pathways of structured knowledge.
It gets not just the what, but the why and the how. That is a much, much deeper level of understanding.
So what does this all mean at the end of the day? What's the big takeaway? It means we can start building AI systems that aren't just more intelligent, but are fundamentally more trustworthy.
And this is not just theory. It's happening right now in the real world. In fraud detection, you can suddenly see these complex, hidden rings of fraudsters. In recommendation engines, you can suggest things based on deep, nuanced connections. In supply chains, you can instantly see the ripple effect of one tiny disruption. This stuff is already a game changer.
And here's the ultimate payoff, the thing that really matters. The AI becomes explainable. Because every shred of information came from that knowledge graph, you can literally trace the AI's thought process right back to the source data. No more black boxes. You get accuracy and you get accountability. You get AI you can actually trust.
So this leaves us with a final, pretty mind-blowing thought to chew on. We're building these structured memories for AIs. What happens when those memories, those knowledge graphs, start to rival the incredible complexity and interconnectedness of our own brains? Now that is a future worth thinking about. Thanks for joining me for this explainer.